two special whole numbers, 0 and 1. 0, remember, was the additive identity. 1 was the multiplicative identity. How do they interact with exponents? Let's first talk about what happens when we take powers of 0 and when we take powers of 1. Let's suppose we have, for example, 0 to the third power. That'll be 0 times 0 times 0. What do we always get when we multiply by 0? When we multiply by 0, we always get the number 0. Does it matter how many times? It doesn't matter how many times. No matter how many times we multiply 0 by itself, we're always going to get 0. There is one remark we're going to make on this in a moment. So I'm going to put a little asterisk by this, any. What about powers of 1? Let's say we want to take, say, 1 to the 4th. Well, we'll multiply 1 times 1 is 1, times 1 again is 1, times 1 again is 1. Is that always going to happen? Well, remember, anything times 1 is just 1. So no matter how many times we multiply 1 by itself, we're still going to get 1 back. No asterisk by this any. By any, I really mean any. Okay. So, 0 to any power is 0, 1 to any power is 1. What about when we have 0 and 1 as our exponent? I'm going to just use 5 as my example here. 5 to the 4th means multiply together 4 copies of 5. 5 to the 3rd means multiply together 3 copies of 5. 5 squared means multiply together 2 copies of 5. So you can see, when we go up a power of 5, we multiply by an extra copy of 5. When we go down a power of 5, well, we multiply by 1 less copy of 5, which is the same as dividing by 5. What should 5 to the 1 be? Well, to go from 5 to the 1 to 5 squared, we want to be multiplying by 5. Or another way to think of it is going from 5 squared to 5 to the 1st, we want to be dividing by 5. Well, that means down here we want to have 1 less copy of 5 than we did up here. 5 to the 1st should be just 5. Okay, that's not that weird, right? 2 copies of 5, 1 copy of 5. That makes sense. This is the weird one. What should 5 to the 0 be? Well, to go from 5 to the 0 to 5 to the 1st, I want to be multiplying by 5. Or another way to think of that is to go from 5 to the 1st to 5 to the 0, I want to be dividing by 5. Well, what times 5 equals 5? Or alternately, 5 divided by 5 equals what? 5 to the 0 is going to have to equal 1. Now 5 is not magic here, right? We could replace 5 in this line of logic by any other whole number except for 0. Any number to the 1st power is just that number. And that even makes sense for 0, right? It even makes sense to say 0 to the 1st power is 0. That's okay. Any non-zero number to the 0th power is 1. Right, just like we take 5 divided by 5 is 5 to the 0, we could take 3 divided by 3 is 3 to the 0, and so on. What about 0? We have One rule that says 0 to the 0th power should be 0, namely the 0 to any power rule. We have another rule, namely the anything to the 0th power rule, that says 0 to the 0 should be 1. That tells us that there's something fundamentally wrong with this 0 to the 0 idea. What we end up saying is 0 to the 0 is undefined. We can take other powers of 0. We can take the 0th power of other numbers, but we cannot take 0 to the 0th power. It's undefined. It just doesn't make any sense.